Alright guys, for 63 through 72 you had to use a graphing calculator if you need it. Again, I know some of these functions you can graph by on your own without using a graphing calculator, but if you need it, you can use it, and then once you graph the function you have to determine whether it's an even, an odd, or neither one. Okay? So start off with number 63, f of x equals 5. That's a horizontal line on the y. It crosses the y-axis at 5. So something like this. So this one is symmetric with respect to the y-axis. So this one is even. 64 is very similar. It's f of x equals -9. It's a horizontal line going across through -9. So this is another even because it is symmetric with respect to the y-axis. Number 65 is a linear function. It's a line. The slope is 3. The y-intercept is -2. So if I have a dot here, go up 3 over 1. So it goes down like this. So as you can see, it's not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. So this one is neither. 66 is another linear function. Negative or 4 minus 5x. So the y-intercept is 4, the slope is -5. So I'll start off by putting a dot over here on 4, then I'm going to go down 5 to the right 1. So it's a very steep slope. This one is not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. So this is another one that is neither. Okay. Number 67, quadratic, is a parabola. The 6 tells you that it got, the parent function x squared got translated up 6 units. So it looks something like this. Okay, so this one is symmetric with respect to the y-axis. If you fold on the y-axis, the two sides overlap each other. So this one is even. Okay, 68, another parabola that was translated down 8 units, and then the negative in front of the x squared tells you that it reflects over the x-axis, so it's going to open down. Oops. Okay, so this one is also even because it's symmetric with respect to the y-axis. Okay, 69, the square root function goes, you can start on 1, and then it goes this way with an arrow here. So this one is not even because it's not symmetric with respect to the y-axis, and it's not odd either because it's not symmetric with respect to the origin. So this one is neither. Okay. Number 70, cube root of t minus 1. So it looks something like this. Kind of curves out this way and then curves down this way. This one is not symmetric with respect to the y-axis, so it's not even, and it's not symmetric with respect to the origin, so it's not odd. So this one is neither. Okay. 71. Absolute value, remember these are the V shapes. So right here, we'd start here, and then it goes this. So this one is not symmetric with respect to the y-axis, and it's not symmetric with respect to the origin. So this one's neither. Alright, for 72, it's another absolute value function. So, let's see, we start on 5. The vertex is at 5, and it's opening down. So it goes this way. Okay, so this one not symmetric with respect to the y-axis and not symmetric with respect to the origin. So this one is neither. For number 79, numbers 79 through 85, they want you to show algebraically whether a function is even, odd, or neither, and graphically. Okay, those are the two parts I wanted you to work on tonight. Okay, you could skip part C for now. So, we go through and replace all of our variables with a negative. Okay, so f of negative t equals negative t squared plus 2 times negative t minus 3. And then you simplify the right side. So then this is t squared minus 2t minus 3. And so you compare the result with the original function. If it's exactly the same, then the function is even. If it's the opposite, then the function is odd. And if neither one of those is true, then it's neither. Okay? So if you compare, you've got t squared, and then this is where it falls apart because you've got a plus t and a minus t. So they're not the same. And they're not opposite either. So this one would be neither. Okay, it's a quadratic function, so we know it's a parabola. You could factor and then graph it that way, or like it says, just use a graphing calculator, plug it in to get the graph. So again, I would factor it because it does factor, and that way you get your x-intercepts, and then you can find the vertex, and it ends up being like -1, -4. Oops, I didn't quite reach that dot on the right here, but that's where it should go through. It should go through 1, 0. And so again, the graph confirms your answer, the answer that you got algebraically. So for 81, do the same thing. We're going to replace all the x's with negative x. Okay, and then simplify, so it gives you negative x cubed minus a negative is positive. And so once you've simplified, you compare your result to the original function. And as you can see here, the function is opposite. So here I have a positive and a negative. Here I have a negative and a positive. So the two functions are opposite each other. So this one would be odd. Whoops. Get to change the pen. Now this one definitely you would plug it into a graphing calculator. And so this is what it looks like. It crosses a little bit past 2, so like about right here, and -2, a little bit past it. And I just use Desmos.com, input the equation, the function, and let's see, it's about this high, and it goes like this, and like this. And if you click on the dots on the Desmos app, it'll give you the coordinates for this point, the low point, the relative minimum, which is 1.291 comma -4.303. And so the coordinates up here are -1.291 comma positive 4.303. Now you don't have to know, know this, but I just want to point out that the signs switch. It's the same number, but that's another characteristic of an odd function, that if xy is on the graph, -x, -y is also on the graph. So notice the x coordinates are the same number but different signs. Y coordinates, different numbers, but same numbers but different signs. Alright, for 83, now this is definitely not a function that you're probably used to seeing, but it's okay. We're going to go through and algebraically show whether this is an odd or an even function. So start off by replacing the x with -x. We're evaluating f of -x. So right here, negative x, square root of 1 minus negative x squared. So then I get negative x, square root of 1 minus, now squaring a negative gives you a positive, but there's a negative already like in between the 1 and the x, so it stays 1 minus x squared. So if I were to multiply f of x, the original function, by negative 1 to get the opposite, this is the answer I would get. So this is the opposite of this. Okay? So this is an odd function. So you definitely need to input this into a calculator. And when you do that, you get something that looks like this. It's like goes through 0, 0, and 1, 0, and negative 1, 0. And about, I mean, I want to say it's about here. About here. Goes something like that. So your drawing confirms that it is an odd function because the ordered pair that they give you for this, again, if you're using Desmos, it has like a little gray dot right here. Right here, it has like a little gray dot right there, and another gray dot right there. So if you click on it, it gives you the coordinates. So this one is 0.707, negative 1/2. And this one is negative 0.707, positive 1/2. Okay, so that's how we know that it's an odd function. For 85, you did study these kind of functions in algebra or integrated 3, functions with rational exponents. So we're going to go through again and do the algebraic work first. So g of negative s equals 4 to the negative s, 4 times negative s to the 2/3. So remember what this means, this power. The 2 is the power, the exponent. So the 2 is the power and the denominator is the root. So that means that we're raising negative s to the second power, okay? And then after that we'll take the cubed root if we have to. But for now, to simplify the right side, remember, this means we're squaring it. So when you square a negative, you get a positive. So that's what you end up with. So comparing it to the original, it's the same function. So that means this is even. So now we're going to compare our answer or verify it with the graph. So when you plug in this function into Desmos, you get something that looks like this. But again, if you fold it on the y-axis, the two sides, the left side and the right side, overlap each other. And that's it.